Okay, so the purpose of this video is to talk about how to multiply rational expressions together. So I've given you, again, because rational expressions are basically fractions, you got to remember how fractions work. So up here, you might not be able to see it because it's very small. I've got a pair of fractions here to be multiplied, and it's 3/8 times 20/12. Now, I could go ahead and multiply these fractions together. And remember, fractions, when you're multiplying them, it's top times top goes on top, bottom times bottom goes on the bottom. But if I did that, I have 60 over 96, which, I'd have to simplify. And if the numbers were any bigger, it would be a little bit more of a pain. I will tell you, for the problems that we're going to be doing, it's going to make a lot more sense for you to simplify before you multiply. So we're going to want to simplify before you multiply. Every time, your life will be so much simpler. So there are two ways of simplifying when you have multiplication problems. The first is to simplify any fractions that you have. So 3/8 can't simplify, right? No common factors other than 1, but 20 over 12 can. So 20 over 12 both have a common factor of 4, so this would be 5 on top and 3 on bottom. And then remember, when you're multiplying fractions together, whatever is on the top of either of the fractions would end up on top of the answer fraction. Whatever's on the bottom of either of the fractions would end up on the bottom of the answer fraction. So we can do something when we're multiplying called cross-canceling, meaning if you have something that's in the numerator of one fraction and the denominator of the other, you can actually cancel those out. It's like this 3 and this 3. Once you've done the simplification of each of the fractions and the cross-canceling, then multiply straight across, and your fraction will be fully simplified already. So simplify before you multiply, and that's done by simplifying the fractions and cross-canceling. Now, and I kind of wrote it here, but really, you could do it on there. Now, we're going to do this with some rational expressions now. So I've got a bunch of quadratics here on top and bottom of both of these problems, so we're going to start by factoring them. And the first thing you always want to look for when you're factoring is a common factor. So on top of this first one, I have a common factor of 4. So that's going to be 2x squared minus x minus 10. And on this bottom, there's no common factor, so just for now I'm going to leave it. I could factor it now if I wanted to. No common factor on the top of the second one. There is a common factor on the bottom of this one, and it's 4. Now I can focus on factoring each of these quadratics. Now, if you don't remember how to factor a quadratic that has an x squared coefficient, remember, you multiply the first coefficient by the constant, that's negative 20. You're looking for two numbers that multiply give you negative 20 and add to give you negative 1. So that would be negative 5 and positive 4. Now, I like to use the box, so I'm going to pull that up here, because I don't have a lot of space. I'll just do it over here. I'll move it when I do the next problem. Your x squared coefficient goes here, your constant term goes there, and the two numbers I just came up with, negative 5 and positive 4, go in this box with x's, and it doesn't matter which one you put in which place. I'm going to pull a common factor out of the first row, which is x, and now I'll just make everything work. So if this is x and this is 2x squared, this needs to be 2x. If this is 2x and this is 4x, this needs to be 2. And if this is 2 and this is negative 10, this needs to be negative 5. So my factors are 2x minus 5 and x plus 2. And don't forget, I had a 4 sitting out in front of all those things. That's a 2, really messy. All right, so the bottom one, going to factor much easier because there's an x squared coefficient of 1. So two numbers that multiply give you negative 35, add to give you 2. That'd be x plus 7 and x minus 5. And then on the top of the second fraction, two numbers that multiply give you 20, add to give you negative 9. That'd be negative 5 and negative 4. And then x squared minus 4 is a difference of two squares. So x plus 2, x minus 2. So just like we did in the simplification process, now is the time we would want to mark what x cannot be. So x cannot be negative 7, positive 5, negative 2, or positive 2. 4 can never equal 0, so we don't have to worry about that. And remember, it's only the denominator equaling 0 that causes the fraction to break apart. Now I can start canceling things. So let's see, I have a 4 here and a 4 here. I have an x minus 5 and an x minus 5. and I have an x plus 2 and an x plus 2 that will cross cancel. So what I'm left with is the 2x minus 5 and the x minus 4 on top, the x plus 7 and the x minus 2 on the bottom. So now, oops, I'm going to go ahead and multiply that out because you would have a quadratic on top and bottom of each of these, right? So that would be 2x squared minus 13x plus 20 over x squared plus 5x minus 14. And that would be fully simplified. I'll do the second problem in a different video, so the video is not so long.